Okay, sorry about that. Okay, starting with the Marche UPSs, the compact and the modular UPS, they're more so designed for data centers, for more critical centers, not necessarily your typical industrial application. Um, these are going to be more so on the side of your telecom type setups, your data center setups, your critical center setups, where you do have a different type of load or an application where you want something smaller as far as maybe size and maybe smaller footprint, higher capacity, and you need it to power up in a smaller general area compared to your industrial UPSs. So now just an overview of the two systems. You got your compact UPS. The compact UPS comes in a 2 RU setup that's typically rack mountable, as you can see on the picture there on the left, and your modular UPS, which is more so of a cabinetized solution, which also comes with different sets of modules, power modules, and battery packs with your overall display and bypass control behind that display. The compact UPS is only available in 1K, 2K, and 3K VA module sizes, and these modules cannot be paralleled. So it's better, more so, if you have any applications for a 3 kVA or under, we would stick with the compact UPS versus a modular UPS, which can handle up to 80 kVA in capacity in the various types of setups with maybe a different cabinet and obviously a significant amount of modules. Some of the basic uh, characteristics or specifications of the compact UPS is going to be obviously rack mountable, but as far as power, they're typically going to be a 120, 230 volt input output, single phase only, so single phase in, single phase out. And the actual voltage ratings on the battery side are going to depend on which module you select. So for example, the 1 kVA is going to be available at 24, the 2K at 48, and the 3K at 72 volts DC. Oh, sorry, here's and I got something pop up. Okay, it looks like, sorry about that. On the modular UPS, we have it set up with different power modules and various voltage ratings. We do have single phase to single phase, split phase to split phase, 3-phase to single phase, and 3-phase to 3-phase configurations. Depending on which one of those power modules selected, you can either have 120 VAC to 230 volts, 400 VAC, and a few other variations in between that are selectable depending on the power module. The battery packs are only available in 2 selective sizes, 120 volts DC or 240 volts DC. And again, these are only mountable as far as a rack type cabinet. And if you have just a single module solution, they can be mounted in that tower mount, which we will see a little bit later on. Okay, now just to focus more so on the compact UPS, here's a little bit more of a setup that we actually have done in the past. The cabinet that you see rotating there was configured for a specific customer where they only needed 2 power modules or a specific number of power modules. They actually had battery racks there as well, but they also had an external battery pack that they could have added to it. So that's why you don't see anything too packed with modules, power modules, or battery packs as well. So it is a double conversion UPS system. So it is your AC to DC and your DC to AC. And it's obviously configured for your critical and non-critical loads. Some of the connections on the UPS as far as the output are through programmable outlets. And then going forward, you will see that some of those outlets do have some non-critical positions as far as the terminal strip that you can see on the back of the module. And then you can actually designate some of those time durations or your priorities on the output side. So the other thing that you do see here in this battery pack, with this power module, you can see different types of battery packs that you can mount with it. We do have a couple part numbers set up already for external battery packs that can be paralleled to allow for a designated amount of runtime depending on your total power capacity. Efficiency is up to 96%, and that's with the eco mode. As far as AC power or battery powered efficiencies, we're probably ranging around 90% efficiency. The compact UPS itself comes with the built-in bypass. So you do have that seamless transition from your AC to DC or whatever priority you set with the unit. The hot swappable battery packs, or there's battery packs internally to each power module, are swappable, so you do not have to necessarily rely on those battery packs for your backup time. You can obviously run those with the external battery packs as well. There, as far as a maintenance concern, those battery packs can be replaced, and I know typically you do see in the market replacements of battery packs ranging from anywhere from maybe around 2 years to 3 years. We do have other options. Options available on this is going to be an SNMP card. I'm sorry, that's actually a standard feature for the compact UPS. SNMP communication, we felt that as a lot of the market is moving in this trend, we would go ahead and make that as a standard feature. As far as programmable load sharing, that refers more so to the outlets on the compact UPS on the back. So you can see those outlets here in the back. I don't know if you can see my cursor, but those outlets can be programmable to load share if you do have more than one load connected. Frequency convert mode simply means that if you do run on a DC backup mode, you have the capability of running your output AC in either 60 hertz or 50 hertz. Inversely, if you are running on AC mode and you are running straight bypass, your AC output would follow your AC input that you have. So if it's 60 hertz, it'll follow 60 hertz, 50 to 50. And again, applications, data centers, networking, IP telephone, any type of critical loads for those more so data center and telecom type applications. Right now, we currently do have a couple UL and CUL TUV ratings. And if you guys need more information, we can definitely go through some of that as well. As far as the power modules on the compact UPS, the 1K module is available at a 120 to 30 and only a 24 volt DC input as far as a DC bus. They are all 2U modules that you see here. The 2 kVA is the same output but runs on a 48 volt DC bus versus a 24 volt on the 1K, and the 3K on a 72 volt DC bus. So what that would simply mean for you is that the battery packs here if you can see the picture on the bottom end, would have to be replaced using a different set of configurations as far as 24, 48, or 72 volts. And again, your external battery packs would have to be ordered to match your DC bus input.
Hey, Bobby, so those
Yes.
Battery packs are 2U also?
They are, yes. So
Okay.
the external battery packs that you would connect to this power module would be 2RU as well. The internal battery packs, as you can see here, they're this little SB style connector. They're just kind of packaged in the series parallel configuration to accommodate your DC bus. As far as transfer time from the AC to battery mode, it's going to be 0 time. From inverter to bypass, we are seeing less than 4 milliseconds transition. And as I mentioned earlier, your efficiency is going to be running around 90 for your AC battery mode, and then eco mode at 96% efficiency. And then your typical environmental ratings, since these are going to be in a controlled environment, we run from 20 to 95% humidity, non-condensing, and then your noise less than 50 dB, and we do have it within those same temperature ratings of your typical 0 to 50 C operation. Now this picture you see on the left side. This is your tower mount configuration that I mentioned earlier. So this is just one simple power module in that stand-up configuration. If you do not have anything else, or if you have a rack or anywhere else to mount it, this is an alternate solution to that. The display in this matter is actually rotatable, so you can actually pop that display out and rotate it depending on the configuration. So we have it in that vertical or horizontal manner, with the keys also part of that display. And then in the back of that module, you do have your internal battery pack. So now with the module on a horizontal axis, you can see the back of the module. You can see where you have your input connect your AC input connections, your output programmable outlets, your external battery pack, which is typically the SB style connector. I'm not exactly sure on the specific number of the SB connector. And you do have an EPO functionality button here that you can wire out if you have that on your system. Oops, sorry about that, something popped up. And then as far as the output circuit breaker, it's only available on the 3 kVA module, so you will not see that on the 1 and 2K configurations. Moving on to the battery pack for the compact UPS. You obviously have that preference of using just the internal battery pack would obviously give you a much smaller runtime, or you can use that external battery connection to start multiplying your backup time depending on your load capacity. But we tried to make it where it's modular and scalable, so you can go ahead and play with those times. Typical backup time for this type of application is going to be anywhere from 5 minutes, 30 minutes. Usually is going to be the most. Anything above that, you're probably going to be better off using a external battery pack, which is going to, external battery racks, probably, because it's going to be probably a much longer, a much larger battery compared to these smaller battery packs that we have currently available for the compact UPS. Right now, all the battery packs and all the internal battery packs that you saw with the compact UPS are VRLA type configurations, but I know that we do have capabilities of actually using lithium iron phosphate style batteries, so the Life PO4 that you see designated here. We currently do not have these prices in the price book or in the data sheet, but if there is a requirement, we would definitely love to hear about it, so please let us know if you do have any of those requirements. Okay, so the battery packs that we have available right now are going to be the 24 volt and 18 amp hours, excuse me, available for the 1 kVA, 48 volts, 18 amp hours as well for the 2 kVA, and then 18 amp hours for the 72 volts power module. Just to go quickly through a couple of your typical runtimes, some of this information is also available on our manual and data sheet. Are going to be noted here. So for your typical runtime, 100% load capacity, you will get about 8 minutes with the internal battery pack across the board, 7 minutes for the 3 kVA unit, and then obviously adding your external battery packs would get you, your runtimes beyond that 30 minutes or even closer to that 1 hour total backup at 100% load. Again, a lot of times you will not maybe necessarily be running at this full capacity. So in instances we do have different settings for the 80% or 60% load capacity that you can see here designated as well. Okay, now as far as the mounting configurations, I showed you that tower mount, which is just a single power module. The rack mount configuration with your typical AR system, your relay rack system, you have here your power module and your external battery pack that can be mounted right alongside each other, both 2RU configurations. And then you have your cabinet style configuration where you can go ahead and mount numerous types of battery packs with your power module here up at the top. Aside from that, this is the only configurations we have currently available for the CUPS mounting. Now going on to some of the LED displays, we do have different types of notifications as far as your statuses, your input, output, battery temperature, and load readings as far as your current readings. different types of configuration programmable outlets, you can actually go ahead from this display and designate your time and priority for those programmable outlets. Some of this can also be done through SNMP. I actually haven't tried it myself, but I have heard and seen through some of the manuals that you can configure some of this information through the SNMP part of the unit. You can designate or see your backup time, and your backup time is something that you have to manually input. So for example, your backup time will go ahead and manually calculate based on your internal battery pack of the module. But if you are going to go ahead and apply additional external battery packs, you would have to manually go in there and update that amp hour rating so as to it's calculating correctly. Fault codes, battery information also shown on the display, and you can actually change your mode of operation as far as your priorities on your AC or DC side. SNMP, again, this is now a standard that we're trying to push with some of our data center style UPSs. And some of this can also be shown in more detail on our manual as well. So I'm not going to go too much into the actual SNMP style configurations. Before I move on to the MUPS or the modular UPS, is there any questions on the compact UPS? Okay. Moving forward now for the modular UPS. So this is again another style of our data center or telecom type UPS. MUPS, designated for modular, is also a pure sine wave, low harmonic distortion, high efficiency. Again, for those critical applications like your hospitals, data centers, and networking telecom sites. So this one now, we start at a 6 kVA module and a 10 kVA module, and we have the capability of paralleling up to 8 of these units together. So that's where you get your total capacity of up to 80 kVA. These again do have a similar style battery pack like the compact UPS. So you have your power modules noted here with a little display and your battery packs right underneath it. They are hot swappable, so you can go ahead and remove these power modules and battery modules. So that does give you a better MTTR, or your mean time to repair, and even a lower MTBF in a lot of cases. You do have a couple mounting configurations. You do have the cabinet style, which are these designated cabinets because they do have a built-in rear bus that you would have to connect with. So it is something that you do have to designate as far as using these cabinets. And you do also have the single modular tower style configuration that we saw with the compact UPS as well. Eco mode operation, we're looking at a 97% efficiency. Same thing with your AC power mode and your DC power mode, you do get a little bit lower efficiency. Ideally, everybody would be using an eco mode operation to keep your units running at that efficiency level that most data centers, most critical areas are looking for as well. STS is built into those power modules, so you do not require any other optional STS or static switch. And then I want to show you here the cabinetized solution. So when you are running, you do have a couple different options as far as the housing that you want to use. So you have your pre-configured enclosures, which allow for, you can see here, the 6-slot enclosure, a 4-slot enclosure, and we also have a customized setup that we can actually accommodate. So this one here, we do have various slots, various sizes. So this is actually a 42 RU cabinet, and we can actually allow for 8 modules, power modules, and then for the rest, or obviously different number, but the rest can be battery packs as well. We have seen different setup, actually different applications that we ran into where we had to use an entire cabinet itself just for battery packs as they were looking for a pretty long backup time. So it definitely can be customized to fit different requirements or different applications that your customer may have. Oh, sorry about that. So yes, just a quick, some few advantages and why we want to use the MUPS. That is hot swappable, scalable, up to 8 units in parallel, modular, smaller footprint. You get that redundancy, and then it is that um, eco-friendly, so you get that higher efficiency. Moving on to some of the power modules of the modular UPS. There you go. So as a standard feature, they all have that frequency range. So I'm not showing this voltage ratings here because that is dependent on your power module. But as a standard, they all have that automatic sensing of frequency range of 40 to 70 hertz. So your typical 50 or 60 hertz applications is not going to be anything special you have to request. Efficiency over 90% depending on the mode of operation. Your noise level is 58 dB. Pure sine wave inverter, harmonic distortion less than 4% at full linear load, crest factor, typical inverter numbers that you do want to see in the market, correct? Now let's move on to some of the voltage ratings of the modules that we have available. So the first one that we have, I'm going to show is the split phase. So this is a 6 kVA module, input of 120 or 208. 110 to 220, 120 or 240. So it is a split phase configuration. So you do have two lines, your neutral and your ground. Your output again can be configured in that same manner, or it'll follow your input. So you can have the same 120 all the way up to 240 output configuration. Your DC bus for this specific module will be 120 volts DC and a charging current of 4 amps, and that'll be actually per module that you will have that charging current. So obviously adding more modules, you will increase your charging current. It is a smaller current, but again, these are built to be used for smaller backup times, not necessarily your, more than 1 or 2 hour type backup. Now, sticking with the same voltage rating, I'm sorry, now with the same style single to single phase, we're going to go with the 10 kVA module, which is a single to single, two-way 220, 230 or 240 can be set up. It's one line, neutral and ground, and it can follow the same output voltages using a charging voltage and current of 240 volts DC with the 4 amps charging current. Some of the other ones we have available as far as your 3-phase. Now we're going to jump into the 3-phase to single phase. So you got your 3-phase input of 360 all the way to 415 with an output of 208 to 240 using a 240 volts DC, 4 amps, and then you have your larger your 3-phase to 3-phase modules here. So you will have same style. Obviously it'll follow the input to your output. So your 208 to 220 input output, and then you have your higher voltage. So that's one of the differences you can see in this model number here. MUPS power module 10 kVA. The LV in this case would stand for a lower voltage module compared to the 3-phase, 3 to 3-phase module you see here, where you have a much higher voltage input and output requirement. Okay, so I will go through an example a little bit later. I don't know if there's any other questions that are coming up right now. But we can definitely go through a couple configuration examples if needed.
Yeah, Bobby.
Yes.
Rick. So size-wise, once you go down to these different ones, does that case stay that same size?
The power module itself is the same size. So this one that you see here is the same physical dimensions that you will see for all of the power modules noted here on this list.
So
okay.
how is that happening?
Well, I mean, you're not using too much current, Rick. I mean, as far as if you look at we do have an updated data sheet that we did put some of our AC current draws. And as far as the DC side, you're not actually using a lot of current capacity either. So I mean, they're relatively small just to have enough power to recharge those battery packs that are going to be shown for the MUPS.
Okay.
And again, I mean, it's another thing you can really thank the technology of the modular UPS. You know, you're using high frequency technology. You're not using, there is no, you know, big old transformer that you can put in there. These things are using, I guess you can say they're transformerless, but there's still a style of transformer in there, not like you would see on your typical industrial UPS. Also want to note, you will see a little bit later on the battery, on the DC side, there is something special that I think does contribute to having a much smaller package design for the power modules. Okay, so just a breakdown on the actual power module itself. You do have your, obviously these are high frequency. You do have a fan. It's fan assisted, so there is also some type of designation or some type of indication of your fan failing. So you do have your LCD display, which is also rotatable. Physically, it doesn't pop it out like the compact UPS, but there is a button to actually rotate it, depending on how your configuration style is. And you do have a few functional buttons on the front of the display to navigate the menu. Probably an easier style to navigate is going to be, again, through the SNMP style communication that comes standard with the MUPS. You do have some of your standard LED indicators as far as your fault on battery. Your line is there, and your bypass is available as well. The operation of the MUPS, so the standard operation mode, you do have a couple options. You do have your standby mode, where your load is not, you do not have it powered off of your actual inverter yet. You do have your line mode, battery mode, your bypass mode, your eco mode, and your shutdown mode. So there is different types of reasons that you would want one or the other. Obviously, if you want to have it going through your bypass all the time, if you want to have it going through your inverter the whole time, you know, running off your battery, since we do have a bypass, a static bypass switch integrated into the system, you can definitely go ahead and designate which one you want to do. Is, you know, if you are having to do some maintenance, or if you're taking out modules or taking out battery packs, you do want to make sure you're safe from that. So we do have different styles or different working modes that you can operate or designate as your priorities. Moving on to the battery pack. So this is what I was talking about a little bit earlier in regards to Rick's question. Oops, sorry. You do have two style battery packs for the MUPS. You have your 120 volts, which is going to be running at a 10 amp hour capacity, and your 240 volts, which is simply, I mean, it's the same battery pack, so it makes sense that it'll actually be running at a capacity of 5 amp hours, half of what you see for the 120 volt battery pack. Now, the special thing with this is that you actually have two strings, I guess you can say. So if you were to ever use an external battery for the MUPS, you would have to use technically a 240 volt battery or two 120 volt DC batteries for this one, and two 240 volt batteries for this one. The reason why is that there is, and you can see here, a 120 volt battery connected between the positive and the neutral. And then you have another 120 volt battery connected between the negative and the neutral. So that in itself is 240 volts DC technically, but you're splitting it. Now, the reason why they're splitting it is because we do have a, depending, and this is totally dependent on the technology, they are using that for the rectification process. So they're using this part of it for the positive rectification process, and this side, negative to neutral, for the negative rectification process. So I think that's also another reason why we are able to get such a lower or a much more compact design for the MUPS. It's a little bit odd. So if you ever do need an external battery that you need to power off of this because you need maybe a much longer runtime, or maybe the customer designates it, you do need to take into consideration you need two battery packs, one for the positive and one for the negative. Okay, any questions on that? I don't know if Rick, maybe that helped with your question earlier?
Yeah, sure.
Okay. So the battery packs that we have here are not, you can't just go ahead and pick them for whichever power module you want. We actually have them designated for a certain power module. So the 120 volt, the MUPS battery 120 volt is only designated for these power modules. And the 240 volt, which is the higher voltage, is usually dedicated for the higher voltage power modules that you can see here. Okay, so that's one thing we need to pay close attention to when configuring batteries for the MUPS. I'm not going to go through a lot of the battery runtimes. Just a quick example of a typical runtime or a battery backup. Using the 6 kVA split phase to split phase module with 3 battery packs. We do see some of our backup times noted here. Again, we did update our data sheet since we sent out that email last week. So it should be up on the website now, showing your AC current draw, I'm sorry, your DC current draws for each power module in case you need to configure, a certain amount of battery packs or even an external battery. Okay, and then here's your actual representation of that connection for your battery side, your battery to neutral, your positive to neutral, and then your negative to neutral. So that is how you see that set up on the back of the power module. Okay, so we definitely want to be careful. So there's an actual a warning or an indication the unit will not operate if you only have one of these connected, or vice versa. If you have a battery to negative only connected without a neutral, it will not operate the system itself. So you will get that warning, you will get that notification on the power module itself that you do not have your adequate connection to your DC battery. Okay, now moving on to the enclosure. Currently, we do have, as a standard offering in this style, 4 enclosures. So you have well, it's technically only 2. It's your 4 slot and your 6 slot, but it's dependent on the power module that you have. So we have a couple. I don't want to confuse this, so if there's any questions, please let me know. For example, here, the split phase to split phase enclosure can accommodate 1 to 2 modules and up to 1 to 2 battery packs. So it's not actually in this picture here, you see you have 4 slots. You cannot automatically just fill this unit up with 4 power modules. You only have the rear cage only accommodates for 2 power modules and for 2 battery packs max. So if you do have any other of those configurations where you need more power modules, that's where we would move you to that customized enclosure where you can accommodate up to 8 power modules or even more battery packs or whatever, however you want to split that power module to battery pack information. So here again, we have some of our 6 slot enclosures, so you can accommodate up to 4 power modules. We do not have it shown here, but you can accommodate up to 4 and 2 battery packs. So that's simply based off the idea that you are always going to have some type of battery backup time. At a minimum, you do need one of those battery packs for your system.
Hey, Bobby.
Yes.
There's a couple of questions that kind of came in about the external battery packs. Is there a limit on the capacity or on the runtime if you use an external battery pack?
There is not.
Or
But
external
again,
battery, I should say.
so yeah, thank you, Don. I can't see some of those pop up here.
Yeah.
So there is no limit technically on the external battery that you would want to use. If you're using, your regular lead acid or NiCad batteries, whatever it is, there is no limit. But you do want to consider that each power module only has a significant amount of charging current. So that's going to greatly affect your recharge time. So you want to take that into consideration when sizing your external batteries.
And Bobby, there's one other question about if a 480 volt input is available on the MUPS.
Right now there is no 480 volts for the MUPS. We do have obviously you're only going to see the 480 from a 3-phase typically to 3-phase. So if you do require a 480 to 480, we actually are looking into a different setup. And obviously we do have your industrial UPS, which would work off of 480 inputs, currently only a single phase output. Okay, Don, is there any more questions, by the way, before I move forward?
There's a couple of questions about if the recording would be available of this.
Yes, I will also be letting everybody have a copy of this presentation. And I am recording this just so we can go ahead and use it for any other future presentations or for anybody else's reference. Okay, so moving forward, you can see here some of the actual, some of the different points of the MUPS. The mimic display here is actually, it's a great display. I mean, it's kind of like our, if you guys were here at our trade fair and saw the IUPS, it's a very similar style. You can actually see where your power is flowing, if it's on the bypass, if it's your line is down or your batteries are down, or if they're charging or discharging. You can actually see all that information and that the flow chart through that mimic display. Through the back here, I want to point out just a couple of things. You do have your different, you know, your I/O here. You do have your controller connections. You do have an input and output AC breaker, and then your AC terminals, and then your battery terminal connections. So you do have a much larger. Actually, it's not even noted there, but it's actually wrong. It should be here, your battery terminal connections. So you do see your positive, neutral, and negative. Okay. Now moving on to our controller. So you did see a little bit of that snippet there in the previous slide. You can see you have different types of different type accommodations as far as your output and input contacts. So this is, you know, definitely something you can go through with more detail in the manual to see how you can set that up and what kind of signals you can receive for that. But I don't want to go into too much detail on that part at the moment. You do have battery contacts to detect temperature of external battery packs. And again, I've mentioned you do have that EPO port for EPO functionality if you do require that on the rest of your system. Your RS-232 USB ports, and we also have an SNMP connection as well on this. You will actually see that, I believe, in this part as well. Okay, as far as your dry contacts, just to point out, we only have it available for 6 output contacts, and we only have it configured for 2 sets of input dry contacts. There, we have looked at other options in case you do want to increase that. So if there is any questions on increasing your I/O capacity, please let us know. So this is not something that we currently have in the price book. Whoops, sorry. Is there any questions potentially on this controller setup? For now, this is all I have as far as for the modular UPS. To end it, I want to kind of give you an advantages versus disadvantage of using these style UPSs. You know, and again, this is more so comparing it to an industrial style configuration UPS. Your advantages are obviously you have higher availability, you do have more capacity as they're modular, so you do have a low MTBF. You do have a much smaller footprint, so you do have more power per your square footprint. And then you do have usually a higher efficiency on some of these high frequency style UPSs. Lower upfront cost, and that's usually designated that, you know, it is because it is the style of technology, it is a lower upfront cost, but it's not, doesn't mean that, you know, you just buy it and forget about it. So moving on to some of your disadvantages, and kind of going for that lower upfront cost, you do have a little bit more of a maintenance that you have to run on this or keep maintained. So that will be one of the disadvantages. There is no isolation transformer like you do see with your industrial UPSs. And then because you do typically want a redundant configuration with your with these style UPSs, it could potentially be a higher cost, or you potentially have stuff as far as spares laying around just in case some of your modules do go out or fail. So that is all I have. Do we have any questions that anybody wants to bring up or mention?
Bobby, Rick,
Yes, Rick.
what is the higher maintenance?
The higher maintenance just comes with, because it is a high frequency style technology, you do have to obviously keep checking up on the system. I'm comparing it more so to your industrial style UPS,
Okay.
or it is a lot more rugged. You just kind of put it in there and you do it works, right? So there is no modularity to industrial UPSs versus these style UPSs, where you do have various modules, you do have various battery packs. So you want to make sure that even your battery packs are still okay, that there is no bulging, there's no overheating of the battery packs. So that's what I'm trying to designate, or
Okay.
trying to talk about when I say higher maintenance.
So did they have any mean time before failure hours on these?
We do not have an actual figure noted right now, but they are going to be, they're not as high MTBF as your industrial
Okay.
configurations. Definitely not. Yeah. So you do definitely want to make sure you're using the right unit or the right UPS based on your application. Again, this is more of a data center telecom style UPS versus your IUPS being more your industrial, your rugged application, your oil and gas, so on and so forth application.
Okay. Are these being marketed by anybody else under another name?
Right. We do not, no, we're not marketing these under anybody else, no.
But I mean, I was assuming y'all aren't actually building these in-house.
Right. So we're not manufacturing these in-house. Obviously, that's due to the technology and to obviously the cost that we want to push with this units to and maintain that low. We obviously are not manufacturing these here at our facility, but we are working with the manufacturer overseas, obviously. So a lot of this technology, or a lot of this setup, is actually Marche engineering that's pushing a lot of these things. But obviously the manufacturing process is not done here.
No, but what I mean is, are they marketing these to other people like LaMarche in the States?
Oh, to
That would
Lamarche? No, definitely not. Mm-mm.
just to LaMarche?
Yes.
Okay.
Now, Rick, that doesn't mean that there is other competitors that have something similar.
Right.
Obviously, there is other competitors that have similar style equipment to the compact UPS and something similar to the modular UPS. Okay, so that doesn't mean that we might be the only one in the market for this.
No,
Right?
I know, but I mean, at some time, would there be a sheet saying, what it might compare to?
Yes. So let me go ahead and actually show you some of that. 1 second here.